So here's another problem type where I'm asked to find the molar solubility of a compound given the KSP value. So the first thing that I'm going to do is I'm going to set up a rice table. Why don't you pause and see if you can get the dissociation reaction for aluminum sulfide. So I have aluminum sulfide, which is going to dissociate into 2 aluminum ions plus 3 sulfide ions. Now, we don't really know anything, except for the initial concentrations of my products are going to be 0. And I'm trying to find the molar solubility of aluminum sulfide, which is going to be, that's going to be my initial for the rice table. Okay, so if I call that X, I know that my equilibrium value of that is going to be 0. So I'm going to make the change minus X. And since these two things are in a 1 to 2 ratio, I can say that this one's going to go up by 2x, and I can say that this one's going to go up by 3x, which means that my equilibrium concentration of aluminum ion is 2x, and this one is 3x. Now that I have my rice table done, I can write my equilibrium expression. Okay, and remember that this has to be concentration of aluminum ion squared times the concentration of sulfide ion cubed. All right, now the equilibrium concentration of aluminum ion is 2 times x. So that's going to be 2x quantity squared. And then the concentration of sulfide ion at equilibrium is 3x. So that's going to be 3x quantity cubed. So this is going to be 4x squared times 27x to the third, and that's going to be 108x to the fifth. And this 108x to the fifth, I can set equal to the KSP value, and then I can solve for x. So x is going to equal KSP divided by 108, so that'll be x to the fifth, equals KSP divided by 108. And then I can take the fifth root of both sides. So x equals the fifth root of KSP, which is 2.5 times 10 to the minus 13, over 108. And that is 1.2 times 10 to the minus 3. On your calculator, you could take the KSP over 108, put it in parentheses, and then raise it to put another set of parentheses, the 1 over 5 power. Okay, that'll give you the fifth root of that. Okay, so 1.2 times 10 to the minus 3 is my value for x, which is the molar solubility of aluminum sulfide. So I just put a molar on this, and that is my answer.